Proline is a bulletin board system built on top of MD Basic, as well as AmperWorks and Modem Works, which are in turn built on top of the Object Module Manager. MD Basic, Modem Works, and the Object Module Manager were developed as part of Proline and later split out into separate products. MD Basic is an enhanced version of AppleSoft Basic. It removes the line numbers we know and love. It adds a C preprocessor with macros and file inclusion. It adds more control statements, similar to those seen in other basic variants. Perhaps the best part is it compiles to compressed AppleSoft, which can run on any computer that runs AppleSoft. MD Basic is a 2GS program. It's available as a GUI or from the command line. If you read juiced.js, you're also aware that it's available as a web app. MD Basic works great with Golden Gate, so you can run it on your modern Mac or PC. This is some sample MD Basic code, the first page or so of the ls command. What you'll probably note about it is that it looks absolutely nothing like AppleSoft Basic. And this is the code after MD Basic gets through with it. You can see it's optimized down into an unreadable and unmaintainable mess, but it's a high performance unmaintainable mess. The Object Module Manager loads, unloads, and relocates modules. What's a module? Well, it's a chunk of machine language code for use with AppleSoft. There is an ampersand command dispatcher which manages the ampersand vector and makes it easy to write your own ampersand routines without stomping over everybody else. It also supports inter-process communication between modules, which, as we'll see in a moment, is very important to the Modem Works design. The Object Module Manager has a well-documented file format for the modules. There is a header, a code section, an immediate table section, and a data section. When the module is loaded, the manager relocates it in memory and patches absolute addresses within the code to point to their current location. To get a better understanding of how Modem Works works, I wrote a disassembler for the modules, which is available on GitHub. AmperWorks, which is included with the Object Module Manager, is a set of 37 ampersand commands. It has string manipulation utilities, it has pro-DOS file utilities, and it has improved versions of some AppleSoft commands. Modem Works is, in its own words, an AppleSoft communications toolbox. It has ampersand commands to communicate with the modem, communicate with the serial port, handle terminal emulation, and send and receive files with X, Y, or Z modem protocols. Modem Works is built on top of several modules working together through inter-process communication. There is a port tool, a modem tool, a time tool, a console tool, a terminal tool, a send tool, and a receive tool. The port tool handles the serial port. There are actually 6 port tools provided for use with different serial port cards. The port tool can read a character with a timeout, or read a buffer. It can also write a character or write a buffer. It can also search incoming data. You provide it with a list of strings, and it will try to match incoming characters against it and let you know which one it was. There are also other housekeeping calls, such as checking if the data terminal ready signal is ready, or the data carrier detected signal is detected. The modem tool handles modem communications. There are 2 modem tools. One is for Hayes AT style modems, and one, the no modem, is for null modems, which is to say computers hooked directly to each other without the benefit of a modem. The Modem Tool has built-in defaults for a generic Hayes modem, but it also supports modem capability files, which specify AT commands needed for a particular modem. It handles messages such as dial a number, handle connect, answer line, hang up, is ringing. And the Modem Tool uses the port tool to read or write all the AT commands to the modem through the serial port. This is a sample Modem Works AppleSoft program to call a phone number. It's quite understandable, fairly straightforward, I do believe. First, we call the number. The ampersand call statement goes through the ampersand vector, and then the Object Module Manager handles the lookup and command dispatching and calls Modem Works. Modem Works sends the dial number message to the Modem Tool. The Modem Tool builds up the AT-DT string and sends it to the port tool via the serial write buffer message. Then the port tool writes the data to the serial port, and of course, the modem interprets the command. Next, we wait for a carrier response. Modem Works sends a handle connect message to the Modem Tool. The Modem Tool asks the port tool to search for the connection status strings: connect, busy, no carrier, and such. After it finds the match, the value is returned back to the Modem Tool and back to AppleSoft through the status variable. Modem Works patches the input and output vectors, so input can come from the keyboard or from the serial port, and output goes to the screen and the serial port. Finally, most importantly, we hang up. Modem Works sends the hang up message to the Modem Tool. The Modem Tool sends the +++ATH0 message to the port tool via the serial write buffer message. The port tool writes the data to the serial port. Answering is similar. This is a small sample program to wait for a phone call, pick it up, and then hang up. First, we sit around and wait for the phone to ring. Modem Works sends the is ringing message to the Modem Tool. The Modem Tool sends the serial add search message to the port tool, searching for the ring text, which is how the modem communicates back to your computer that the phone is ringing. The port tool searches for the ring message, and once it's found, returns the status back to the Modem Tool, which returns the status back to AppleSoft Basic. And if you get tired of waiting, you can hit a key to cancel. Then we need to pick up. Modem Works sends an answer line message to the Modem Tool. The Modem Tool sends an ATA command to the modem via the port tool serial write buffer message. Waiting for the carrier and hanging up are the same as before. KEGS has serial support. KEGS has modem support. The problem is it has to guess the intention based on what's written to the serial port. The other problem I found is that it was not reliable. I tested it and found that after waiting around for a while, the port became unresponsive. If we take a big overview look at what's happening, Proline calls Modem Works, which calls the Modem Tool, which calls the serial tool, which writes to the serial port and software modem within KEGS, which then finally communicates over TCP. My approach was to create a custom modem tool and a custom serial tool. They interface with KEGS directly through the WDM opcode instead of indirectly through the serial port. KEGS handles all the Modem Works messages directly. KEGS opens a TCP connection for dialing out and listens on a TCP port for incoming calls. If we look at what's happening, Proline calls Modem Works, which calls the Modem Tool, which is just a shim into KEGS, which handles all the work and reads and writes over TCP. So here is an updated program for calling with the new Modem Tool and Serial Tool. The only difference is we now call with a URL instead of a phone number. So Modem Works sends a dial number message to the Modem Tool. The Modem Tool tells KEGS to handle it. So KEGS sees the dial number message and opens a TCP connection. Both Telnet and SSH are supported. Next, Modem Works sends a handle connect message to KEGS. KEGS checks the TCP connection status. Then to hang up, Modem Works sends the hang up message to KEGS. KEGS closes the TCP connection. The code for answering looks identical. When KEGS receives the is ringing message, it opens the TCP port if it was closed and this was the first message it's received for that. Then it pulls the TCP port for an incoming connection. When KEGS receives the answer line message, it accepts the incoming connection. Now, KEGS is normally a GUI program. After all, the 2GS is all about graphics and sound. KEGS is a cross-platform program. It has multiple drivers for the Macintosh, SDL, Win32, X Windows, etc. To run Proline in the cloud, I created a headless driver. The headless driver has no screen, no keyboard, no mouse, no graphics, no sound. It runs on the command line or in the background. There is one debugging facility. If I send a SIGUSER1 signal or a SIGINFO signal, it will dump the text screen. So, in conclusion, my Proline BBS is a headless KEGS running on an Amazon EC2 Linux server. It's mostly stock Proline. There are custom modem and serial tools which interface with KEGS directly to give improved TCP performance. You can connect today. Telnet to proline.ksherlock.com, port 6523. Log in as guest, cowsay, or add user. And thank you.